Hi everybody, in this video we're going to talk about a very special case which involves a limit of sine of theta over theta or theta over sine of theta. It goes both directions, so the same rule will apply either way. So we're going to look at it for just one of the cases, and you guys can use it as an extra time for you to graph it and look at the other case. So a very useful limit involving the trig function sine is shown below. So we have a graph of sine of theta over theta. You can see it there. Now we can actually prove this theorem using the sandwich theorem, which we talked about in a previous video. And you guys can go read that. It's in the textbook. But for today, what we're just going to do is we're going to look at the graph of sine of theta over theta and confirm what the limit would be. Now notice we're interested in what happens as theta approaches 0. Any other case is a totally different question. So just be careful of that. Now, why is this a little bit tricky? Well, for one thing, if you try and plug in 0 for theta, sine of 0, what is sine of 0? 0. And 0 for theta would be 0. So that'd be 0 over 0. Well, 0 over 0, we've already mentioned that a couple times. This is something that we don't understand. We call it an indeterminate form. When you have an indeterminate form, that means you have to use a different tool to figure out the limit. So what we're going to do is we're going to look at the graph. So we're going to use a visual understanding. So let's approach 0. So 0 for theta, notice theta is the x-axis in this case. Theta is 0 on the y-axis. So we're going to approach the y-axis from the left, and we're going to approach the y-axis from the right. Either direction we approach from, we're actually approaching this point here. This is a point where the function is undefined. It's an open circle. Why is it undefined? Because the denominator would be 0. But the limit is not affected by a single point missing. The limit is what you're approaching. So if we approach from the left and approach from the right, we're approaching this point here. What value does that point have? If you look, it looks like it has a value of 1. Now, graphing is not technically the best way to prove something because you can zoom in and get a more accurate picture, but you can always zoom further. So because of the fact you can never zoom in enough to say beyond a shadow of a doubt this is the value, that's why we need the sandwich theorem. But for today, we're just going to use the visual, and y'all can read about the proof in the book if you would like. So what did we just discuss? If you have the case where you have sine of theta over theta, and theta goes to 0, the answer to the limit is 1. If you turn it around, if you flip over the fraction, theta over sine of theta, that limit as theta approaches 0 is also equal to 1. Something that's very important. Theta has to be in radians. If we're talking about degrees, then things change. So you have to be cautious and make sure you know that theta is in radians. So I want to show you an example of what you might be asked to do. So let's keep the formula on the screen. There we go. All right, so here's an example. Find the limit. Notice it's not theta. That's actually a good thing because we're actually going to have to do some transformations to our problem because it definitely does not look like our formula up above. So what you're going to do when you have a problem involving sine of a function of some sort, so in this case the function inside is the 2x, over another one involving the same variable but maybe a different number, is you're going to try and figure out what theta would be. So theta is whatever's inside of the sine. So you have to figure out what's inside of the sine because that's going to be your theta. So in this case, inside of the sine is 2x. So that is going to be our theta. Well, the formula says if we have sine of theta, then we need theta in the bottom as well. So in order to use our formula, we're actually going to have to do a little bit of algebra. So as x approaches 0, we have sine of 2x, that's our theta, the whole thing in there, divided by what we want to have on the bottom is 2x. Do we have that in the bottom? No, we don't. We have 5x. So how can we fix this? What you're going to do is you're going to separate. You're going to write two separate fractions and multiplication in the middle. The 5 I do not want, so I'm going to put him on the other fraction away from what I'm really wanting. The x, however, remember 5 and x are multiplying, so you can separate them across this multiplication here. So we want to keep the x, right? So the 5 we don't want, we move it away. X we do want. Now, I need theta 2x in the bottom. Well, if I want 2x in the bottom, I'm going to put it there. Can I just do that? No, you have to make up for it. If you put a 2 in the bottom, you also have to put a 2 in the top, because that would be the equivalent of multiplying by 1, 2 over 2. So put in what you need, but then you have to do the opposite. So if you put a 2 in the bottom, you have to put a 2 in the top as well. All right, so how does this help us? Well, this guy 2 over 5 is actually a constant, so he can come out of our limit. So we can take the limit as x goes to 0 of sine of 2x over 2x. Now, a little bit of technicalness here. If we consider the 2x to be our theta, what did we need theta to approach? We needed theta to go to 0. Is the theta, the 2x, going to 0? Well, let's find out. If x is going to 0, what is 2 times x going to? Well, it's going to 2 times the 0. So that means 2x is approaching 0, so theta is approaching 0. In most of our problems, you're going to notice that this is automatically going to work for you. However, this is something you technically need to check as you move forward in calculus. So don't get too lazy. Make sure whatever you consider to be theta is going to 0, as whatever is taking the whatever is approaching 0 in the limit definition is actually making the theta go to 0. You need to go to 0. All right, so now that we have all of that, this limit here, because we have the thetas and they're going to 0, this limit is equal to, according to the formula above, 1. Don't forget the 2 over 5 out front. That's a common mistake. So 2 over 5 times the limit, which was 1, is equal to 2 over 5. So this is the limit of the original problem. All right, I have one more here. See, this was one where we had sine to begin with. But I have one down here where we don't have sine to begin with. We actually have no sines to begin with. So what would I do here? Well, typically we would start off with our plug it in and see if it works rule. If I plug in 0, what happens? So plug in 0 for all of the t's. Well, I already see on the bottom we're going to have a problem. We're going to end up with 0 on the bottom. 3 times 0 is 0. Tangent of 0. Do you remember what tangent of 0 is? You guys might need to review your trig rules, your trig angles. Tangent of 0 is 0. Secant of 0. What is secant of 0? Well, secant is 1 over cosine. So 1 over cosine of 0, that's 1. So this is 0 over 0. All right, so we can't just plug it in. That's when we start wondering, okay, what other rules do we have? Well, it's involving trig. I wonder if we can get sine of theta over theta, or the other way around, theta over sine of theta. Well, to do that, I need to get sine somewhere in here. So how can I get a sine function into this problem? Well, let's use some trig identities. What is tangent? Tangent is sine over cosine. Don't forget to put the t in the top and the bottom. Times, notice I'm separating stuff out. I'm going ahead separating because that's going to help me analyze better. Secant of 2t. Secant is 1 over cosine of whatever the angle was, it stays inside. Don't forget that bottom, the 3t is still there, okay? All right, now, what are we going to do? Let's see. Well, I have my sine now. In order to use the formula, I need sine of theta, which in this case is t, over t. Can I get that already, or do I need to bring in a t? Let's think about that. Well, limit as t goes to 0, I have sine of t. I'm going to move the cosine of t over because I don't want him. So let's move the cosine of t over. He can join the cosine of 2t. That's fine. Now I need a t underneath. Do I have to bring one in, or do I already have one down there? Remember, this 3t, we can separate the 3 and the t because they're multiplying. Let's put the t underneath the sine and the 3 underneath the other one because I don't want the 3. All I want is theta to be t. So theta and theta. So in this case, you didn't have to bring anything new in because you had what you needed. You just had to rearrange and reorganize. Now, on top of this other fraction is nothing, so I'm going to put a 1 there because nothing would be bad. That'd be a 0. So it's a 1. It's a placeholder. So what we're going to do is we're going to take the limit. If we can take the limit of each fraction separately, we can then multiply the limits together if each one is defined separately. So let's try. If we take the limit of, let's see, sine of t over t, as t goes to 0, just pretend these are all thetas. Our formula applies there. Times, we're going to take the limit of the second fraction. 1 over 3 cosine of t, cosine of 2t. Okay. I'm writing down a lot more than you really need to. You can shorten this. I'm trying to show you all the details so that you understand what's happening, I hope. All right, so this first limit here is our formula. As t goes to 0, sine of t over t goes to 1 times the second limit. Okay, we got to plug it in and hope it works. If it doesn't, then we need another tool. What is cosine of 0? If t goes to 0, plug in 0 here. If we plug in 0 for each of these t's, what's cosine of 0? Isn't that 1? So this is 1 over a 3. Cosine of 0 is 1. Cosine of 0 is 1. So we just end up with 1 times 1 over 3, or 1 over 3. There's your limit. All right, I hope that was helpful. Make sure you practice. If you have questions, remember to ask. Good luck, study hard, and I'll see you in the next video.